This video is about graphing polynomials. And so before we get into graphing, let's go over a little bit of a review here. So for our polynomials, if you remember, we have end behavior. If a function's even, then we know at the ends it's going to look like this. And if it has a negative leading coefficient, it will look like this. So x to the fourth, x to the sixth, x to the eighth, any even. And if it's odd, we know it will have this for its end behavior. And if it's got a negative leading coefficient, then it will have that. Okay, so looking at these functions, we have x squared here. We know the end behavior of this is like this because it is even. And if it's even with a negative leading coefficient, we know it will look like that at the end, and it'll do some stuff in the middle. And if it's odd, we know it will look like this. And again, if it's not in descending, you really need to find the leading term, the one that is the biggest. So that's x to the seventh. That's odd. So it will also look like this. There's no negative here, so we know we're going to have that shape. Okay, so now moving on to polynomials, we now know the end behavior. We also know zeros. So when we graph these polynomials, we know that our function here will cross 0 or hit 0 at our zeros. So when x minus 3 equals 0, so at x equals 3. When x plus 4 equals 0, so at x equals 4. And so remember, it's just the opposite of that number. And so also at x equals 0. So we know at 0, that's negative 4, and 3, our graph is going to come through and hit here. And so what we also now need is that end behavior. We need to know, does our graph do this? Does it do this? Does it do this? We don't know until we find our leading coefficient and our leading term. So how to do that is you just take the leading term in each of these tiny little polynomials that we have here. So our first one would be x. This middle one would be x, but it's got a multiplicity of 2, so it'd be x squared. And the last one would be x cubed. And so we have a positive, and a positive. Putting these together by multiplying gives us x to the 6. So we know it's an even with a positive here. So we know our graph has to do this for its end behavior. So now the rest is just connecting the dots. And there's a nice little connection here between each of these zeros as you move along. So let's look at some graphs in Desmos. So you can see here we have a 0 of negative 1, 2, and 5. So there's our negative 1, there's our 2, and there's our 5. And you notice at each point it makes these special shapes. So if you notice here, it looks like an odd, right? And here it looks like an even. And here it's a straight through. Well, the exponents tell you the shape it makes at that 0. So if it has a power of 2, then at the 0 of negative 1, you get a parabola. See, you get that parabola. And if it has an odd, it's going to give you an odd shape. Now, it doesn't matter about the sign being negative or anything. It's just as it comes through. So if we look at this, we have an x squared, an x cubed, and an x. That's x to the 6. So our end behavior has to do this. So as it connects, it comes in, it has to make a parabola, and then it has to go back down, and it has to make an odd shape. So that's the reason the odd shape looks like this. So it just makes that shape, and then it comes back through. And the last one's a line. See, so it just goes straight through. So it makes the shape. If you look at each 0, it will make the shape of its multiplicity. So let's look at this one. So again, we have a negative 1, 2, and 5. Negative 1, 2, and 5. But we have an odd at negative 1. See how it makes the odd shape? And we have an odd at 2. See the odd shape? And we have a line at 5. And if you add these up, we have 3 plus 1. That's 7. So you see the odd shape, how it goes down and then comes up. So that's our end behavior from there. Let's look at one more. So now I've put a negative 2 in front of it. And so again, the same values. We have negative 1, 2, and 5. I'm just using the same zeros, just changing the exponents on them. So we have an even. So see, even, line, linear. But now I put a negative here. So we have 2, 4, 5. That's an odd degree. So normally the odd would go down, and then up. But since I put a negative, it gives us the negative view. So looking at this one, we have negative 2, x squared, and x. So that would be negative 2, x to the 5th. And that's this end behavior because it's got a negative, right? And you can see it. There's our end behavior. So from the very first 0 and from the last 0, it makes that end behavior. So when we connect these, all we're going to do now is connect them with the shapes. So I like to mark it. So for our 0 of 3, we know it's a line. So I just like to draw a little line. In fact, we don't even need the arrows, just a line. The x plus 4 has a multiplicity of 2, so we know it's going to make the parabola shape. Could be an up or down, we don't know. And then the x, the 0, is going to be an odd shape. So we have to make sure that they have these shapes going through each point. And we're going to put them in order so that we have it. So we know negative 4 is first, and then 0, and then 3. Negative 4 is a parabola. 0 is an odd multiplicity, and then 3 is a line. And then we double check it. So 3 is the line, 0 is an odd, and negative 4 is a parabola. So at the negative 4, we need to make the U shape. So we know it's going to make that shape. So see how it goes back up? And then it's got to come back down to 0. So know what happens at 0. 0 wants the odd shape. So I'm going to have to erase a little bit, go back, and then from here, we need to have the odd shape. So when it connects, it looks like that. And then it's got to come back down to this guy. And 3 is just a line. So I can erase this green and go straight through like that. So there is our graph. There's the negative 4, which is the parabola. See, multiplicity of 2. There is 0 with an odd multiplicity. And there is our final 3 with a 0. So you're doing these 3 steps. You're finding the zeros, drawing the end behavior, and then number 3, using the multiplicity. And you'll get a perfect graph every time. Well, not perfect, but a quick rough sketch. So here, what are our zeros? We have x equals negative 1 and x equals 2. And they're in order, so we know it have a negative 1 and a 2. So now that's number 1. Number 2 is end behavior. So we have a negative and then an x cubed and then an x to the 4th. So as you move along, it's negative x cubed x to the 4th. So that would give us negative x to the 7. So a negative odd looks like that. So we now know to go to our first and go up, and to our last and go down. Now we just need to connect them using their multiplicity. So for number 3, we know that negative 1 is an odd, so it has this shape. And 2 is an even, so it has this shape. So going through negative 1, we need to connect it with the odd. It should always look like the odd, not like a line. So you can tell the difference between this one and this one very clearly. And it needs to always show that. We come down, come back up, and then we know the last one's even, so it does this. And there is our rough sketch. So you should always have that multiplicity going on at each 0. All right, let's look at another one. Let's just add some more zeros here. So we have x equals negative 4, 0, 2, and 5. So let's put them in order. Negative 4, 0, 2, and 5. So they're already good to go. They're in order. It's like they were planned that way. Negative 4, 0, 2, and then 1, 2, 3, 4, 5. Right there. So there's our zeros. That's number 1. Number 2, we need end behavior. So we're just picking the leading terms of each parenthesis. So x squared, x cubed, x to the 5th, and x. And there's no number in front, so we have a positive here. So this is x to the, that's 8, 10, 11. So it's an odd. And there we go. So from the last guy, first guy, we go down, and the last one we go up. So 2, 3, 5, that's 11. Looks like that. Now we just connect them with their multiplicity. So negative 4 is a square. So we should have that shape. 0 is a cube, so that shape. 2, so let's just put it that way. 2 is a 5, so again, the same shape as we have for 0. And the last one's a line. So at negative 4, we make the U shape like that. And then we come back, and we're going to connect with 0. 0 is that S shape, so it has to look like that. And then we connect. Now don't cross over like I just did. We want to make sure that these are still functions. So you don't want to be drawing this. It doesn't do that kind of thing. It should always be 1 point. All right. Now we got to connect with the 2, and the 2 is also the same shape. So as I go up, I've got to come back down, and I need to connect with that same shape. See? Like that. And then finally we go down, come back up, and it's straight through for our line. So there is our rough sketch. Okay, so for the last one, it's yours. I want you to find the zeros, find the end behavior, and then use the multiplicity to graph it. So hit pause now and give it a shot. So it's the exact same graph. So I added a negative here and a negative here, but I put the negative here inside the square. So as you can see, when you take a negative x and square it, it stays positive. Not going to change its end behavior. And at the last one, I also threw in a negative. So this negative cancels this negative. You can see how the signs change. So you got to be careful. Remember, this may look like a 4, but since there's a negative in front, if you solved it, it will give you negative 4. Just like this would give you negative 5. You're just plugging in the numbers that make it 0. So if you got this graph with this information, you're good. Thank you.